Welcome to the Deep Dive.
Great to be here.
Today, we're digging into some prehistory. We're exploring the world of paleontology, and we're looking at a pretty recent dinosaur discovery, Bayannurosaurus. You shared some great material, the scientific paper, an encyclopedia entry.
Yeah, some good stuff to work with.
So our mission today, really, is to figure out what this creature was all about. When did it live? Where? And importantly, why is its discovery actually significant for dinosaur research?
Exactly. Think of it like we're paleontological detectives using these docs.
Right.
And yeah, the focus is Bayannurosaurus perfectus, lived during the early Aptian period.
Okay, early Aptian, that's early Cretaceous. Right?
That's right, part of the early Cretaceous.
Yeah.
And the fossils, found in China's Bayan-Gobi Formation.
Got it. And that name, perfectus, that sounds promising. The sources really stress that the main specimen, the holotype, it's incredibly well preserved.
Oh, absolutely. It's not just hype.
Like a nearly complete skeleton, even the tail.
Yeah, nearly complete, partly articulated, meaning some bones still connected. And yes, the entire tail. That's pretty rare.
Wow. That must be like hitting the jackpot for paleontologists.
It really is. Usually you're working with bits and pieces. A tooth, maybe a limb bone if you're lucky.
Right. Just fragments.
Exactly. So getting a nearly whole skeleton, especially fragile bits like the tail, it gives you an unparalleled look at the whole animal, its anatomy.
Which lets you be much more confident about, well, everything. Size, movement.
Size, movement, and crucially, where it fits in the bigger picture, the dinosaur family tree. It makes a huge difference.
Okay, so how did this amazing find actually happen? The sources say summer 2013.
That's right. Summer 2013, there was a joint expedition in the Chulumiao area of Bayanur, China.
And not just one group, right? It was collaboration.
Yeah, a collaboration. The Longhao Institute of Geology and Paleontology worked with the Institute of Vertebrate Paleontology and Paleoanthropology.
That's great. Different teams pooling resources.
Definitely. And they found it in a very specific layer, the middle of the upper half of the Bangjibi Formation.
And that's important because...
Because geology gives you context. That layer acts like a timestamp. It confirms the fossil is from the early Aptian, pins it down in deep time.
Right, gives you that precise age. And this incredible find, where is it now?
It's housed at the Inner Mongolia Museum of Natural History. Its official designation is IMMNH PV000001.
IMMNH PV000001.
Got it. So found in 2013, but the formal announcement came later.
Yeah, it took a few years for the detailed study and description. It was formally named Bayannurosaurus perfectus in 2018.
By Zhu Jing and his colleagues. A big name in Chinese paleontology.
A very big name, yes. Yu Jing's team did the formal description.
And the name itself, Bayannurosaurus, we sort of broke down, but it's basically lizard from Bayanur.
Pretty much. Bayanur the place, plus sauros, Greek for lizard. Standard practice, really.
And perfectus, as we discussed, points directly to that amazing preservation.
Exactly. It honors the quality of that first and so far only specimen. Okay, let's switch gears a bit. Where does Bayannurosaurus fit in the grand evolutionary story of dinosaurs? The sources put it in Ornithopoda, and then more specifically, Ankylopalexia. Can you maybe unpack those terms for us? What do they tell us about this dinosaur?
Okay, sure. So Ornithopoda, that's a really big, diverse group, mostly herbivores, plant eaters. Yeah. Includes everything from small, fast ones to, well, much bigger ones.
Right.
Ankylopalexia is a subgroup within Ornithopoda. The name actually refers to a key feature, ankylos meaning stiff or fused, and pollex meaning thumb. They often have this characteristic thumb spike.
The thumb spike. So
Yeah.
Bayannurosaurus had one, and the sources also call it a non-hadrosaur form Ankylopalexian.
That sounds specific, like it's leading somewhere.
You got it. It's about its position on the family tree. Phylogenetic analysis, that's how we map these relationships, puts Bayannurosaurus in a really interesting spot.
Okay.
It's seen as more derived, more evolutionarily advanced than an earlier one called Hypsilspinus.
But it's less derived than Tyrannosaurus. And Tyrannosaurus is closer to the heterosauriforms.
And duck-billed dinosaurs. So Bayannurosaurus is sort of just outside that main duck-billed group.
Precisely, just outside. That makes it a really important transitional form. It's bridging a gap.
Wow. So finding this one fossil gives us a snapshot of that evolutionary process in action, seeing the steps towards the duckbills.
That's exactly it. It shows us some of the anatomical changes happening along that lineage. The paper actually has a cladogram, the tree diagram.
Yeah, I saw that visual.
You can see Bayannurosaurus nestled right there. It's positioned after things like Camptosaurus and Hypsilospinus, but before Tyrannosaurus and the true hadrosaur forms like Iguanodontidae and Hadrosauridea, it visually highlights that intermediate stage.
It really shows how these different features were developing over time. Fascinating. And size-wise, the sources mentioned it was big.
Oh yeah, a large iguanodontian. The estimate is up to 9 meters long.
9 meters, that's nearly 30 feet.
Yep, about 30 feet. A substantial plant eater moving through that early Cretaceous environment.
And because the skeleton is so complete, including the tail, that estimate is pretty reliable.
Much more reliable than usual. Often you're estimating from just a few bones. Here, having the whole tail, all those vertebrae, it gives a much better sense of the total length and overall proportions. A clearer picture of the living animal.
Makes sense. Now, beyond just the animal itself, its discovery apparently tells us something about where dinosaurs were living and how they spread out, right? The biogeography.
Yes, that's another really interesting angle. Its presence in Asia, as an early Ankylopalexian, kind of complicates the story we had for this group.
How so? What was the previous thinking?
Well, the analysis by Yu and his team suggests Ankylopalexia might have originated in North America, maybe back in the late Jurassic.
Okay, North America first.
Then potentially a dispersal event into Europe.
Right, so North America, then Europe.
Yeah.
Where does Bayannurosaurus in Asia fit? Is it part of that European wave?
That's the key thing. It seems not. The emergence of Bayannurosaurus looks like a separate event, a distinct speciation that happened in Asia.
Ah. So not just one migration out of North America, but maybe multiple movements and separate evolutionary paths on different continents.
Exactly. It suggests an independent Asian lineage developing, separate from, say, a later migration that seems linked to the origins of the Hadrosauridea group. It adds layers to how these dinosaurs moved and evolved across the globe, much more dynamic than a simple A to B to C story.
So it paints a more complex, maybe more realistic picture of dinosaur distribution.
Definitely more complex, yeah.
Okay. So let's wrap up our deep dive on Bayannurosaurus perfectus. We looked at this large, early Cretaceous dinosaur from China. Really remarkable because of that stunningly preserved fossil.
The perfectus specimen, yeah.
Its place in the family tree as an Ankylopalexian, just before the hadrosaur forms really took off, gives us crucial clues about the evolution of that whole group.
Absolutely. It's a key transitional fossil.
And finding it in Asia shakes up the old ideas about how these dinosaurs spread across the continents, suggesting a more intricate pattern.
Right. Multiple events, different regions involved.
That perfect preservation really is the star here, isn't it? It gives scientists this incredibly detailed look at the anatomy of these early forms.
It's a unique window. Allows for meticulous study of features and understanding those evolutionary transitions much better than fragments ever could.
It really makes you think, doesn't it? How just one fossil, if it's preserved well enough, can fundamentally shift our understanding of life's deep history. And you have to wonder, what other secrets are still buried out there in the rocks? What discoveries are waiting to challenge what we think we know about evolution?
Always more to find. That's the exciting part.
Definitely something for you to ponder. Thanks for joining us on this deep dive.